Okay, continuing with our lessons. Okay, today we're going to work on lesson number 11. Okay, you can find these exercises and topics on page 63 on your books. Okay, so we're going to continue working with trigonometric functions. Okay, we're going to find the sine, tangent, cosine, cosecant, secant, and cotangent of trigonometric functions of a right triangle. Okay, now depending on the exercise, they're going to ask us to find certain things. For example, here we already have the three sides of the right triangle, so we don't have to use the Pythagorean theorem to find the sides. Okay, what we're going to do is we're going to find the measurements of the angles, okay, of the triangle. Now, we already have one measurement of one angle, which is angle C. We already know that angle C is 90 degrees, okay, but we need to find the other two, and we're going to use them with the sides of the triangle. Okay, so we're going to find the sine, okay, of angle A, okay, of angle B, and we're going to find each trigonometric function. Okay, so sine of A, cosine of A, tangent of A, okay, and the same thing for B. We're going to find the sine of B, cosine of B, tangent of B, sorry. Okay, so using what we already know, and let's review it here. Okay, let me put it here so that it's okay. The made-up word that we find is SOHCAHTOA. Okay, remember, sine, opposite hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Okay, so let's find the trigonometric functions for angle A, okay, which is this one. Okay, so angle A, we know that according to SOHCAHTOA is sine, okay, is opposite over hypotenuse. Okay, so it's going to be opposite over hypotenuse. Okay, so sine of A is equal to 45 over 51. Okay, the cosine is going to be 24 over 51. Okay, and the tangent, remember that tangent is TOA, opposite over adjacent, so it's going to be 45 over 24. Okay, now how do we solve for these angles? Okay, remember that when we have sine of A and then we have a number, we need to do the inverse. Okay, we use the inverse operation. Okay, so we have sine to the minus 1 of 45 over 51. Okay, it's not going to fit, but let's do it here. Okay, so we have opposite of sine, okay, sine to the negative 1 of 45 over 51. Okay, so 45 over 51. Okay, look. And the measurement of this angle is 61.92. Let's round up. Let's say 62. Okay, so this is 62. Okay, it's here. Sorry, it's because of the space. Okay, I'm going to use more space here. Okay, so this one, we already know that's going to be inverse cosine of 24 over 51. Okay, so we come to our calculators. Inverse cosine of 24 over 51, 62. Okay, and tangent of 45 over 24. Okay, so we know that it's inverse tangent of 45 over 24, 62. Okay, so this is how we know that our answer is correct. Okay, because if you notice, all of them gave us the exact same angle. Okay, so what is the measurement of angle A? Here, 62. Now, we can use what we already know about the addition of internal angles to find angle B. That would be 90 plus 62 plus B has to be equals to 180. Okay, so we can use that formula, no problem. Okay, but we are using trigonometric functions. So let's use trigonometric functions. Okay, so now we want the measurement of angle B. What do we use? Same thing. Cosine of B, sine of B, tangent of B. Okay, we're going to do them all so that you can notice that the answer has to be the same. Okay, but technically we only need to use one because they're going to give us the exact same answer. Okay, but let's do them all so that we can confirm that they are correct. Okay, so cosine of B, okay, according to SOHCAHTOA, okay, cosine of B would be first adjacent, right? So adjacent over hypotenuse. So cosine of B, okay, is going to be 45 over 51. Okay, so that means inverse of cosine 45 over 51, and that's going to give us, okay, let's do it. Inverse cosine, okay, of 45 over 51, 28. Okay, so 28 degrees. Let's do the next one. Sine of B. Okay, here. Sine of B would be, according to SOHCAHTOA, opposite over hypotenuse. Okay, so it's going to be, remember that we are here, right? Okay, so sine would be opposite 24 over hypotenuse. Okay, so 24 over 51. Okay, then we know it's the inverse operation. So sine to the negative 1 of 24 over 51. Okay, and let's do it. Okay, inverse sine of 24 over 51, 28. Okay, let's do the tangent of B. Tangent would be, according to SOHCAHTOA, would be opposite over adjacent. Okay, so it's going to be 24 over 45. Okay, so we know it's inverse tangent 24 over 51. Okay, so we're going to say inverse tangent of 24 over, oh wait, not 51, 45, sorry, 45 of 45, and that is 28. Okay, so that's how we know that they are correct, because they give us the same angle. Okay, and we can make sure if B, we already know that is 62, okay, from here, then sorry, A is 62 and B is 28. Okay, so we know 62 plus 28, 90 plus 90, 180. Okay, so that's how we know that it is correct. Okay, let's move on to the next one. Next one, same thing. Okay, we have the three sides, and we want to know the measurement of angle A, angle B, and we already have angle C. Okay, so we start to work. Sine of A, cosine of A, tangent of A. Now, to save some work, let's only use one. Okay, because we already know that these two are going to give us the exact same answer. Okay, so let's use only one. For angle B, let's use only one as well. Okay, because we already know, and we proved it here. Okay, that sine of A is going to give us the exact answer. Cosine of A is going to give us the exact same answer. And tangent of A is going to give us the exact same answer. So that means that we can use either one to find the same value. Okay, so we did all of this just so that you can confirm that they are exactly the same. So here we only need one. Okay, so let's use sine of A, which is this one. Okay, let's use sine of A to find the measurement of angle A, and we're going to use cosine to find angle B. Okay, so let's use A and let's use sine. Okay, so according to SOHCAHTOA, sine of A would be the opposite, which is this one, over the hypotenuse. Okay, so sine of A is equal to 80 over 89. Okay, we apply the inverse operation of 80, okay, over 89, and that is, okay, inverse sine of 80 over 89, 64. Okay, and we already know that this is correct. Okay, so angle A is 64. Okay, we already know that we can add this one plus this one plus this one, and it's going to be 180. But let's use the trigonometric function. Okay, so cosine of B, okay, is, according to SOHCAHTOA, adjacent over hypotenuse. Okay, so it's going to be cosine of B is equal to 80 over 89. Okay, we apply the inverse, 80 over 89, and we have the measurement of this angle. Okay, inverse cosine of 80 over 89, 26. Okay, do we know if this is correct? 64 plus 26, 90. Plus 90, 180. Okay, so we know that B is 26. Oh, wait, sorry. This is the correct, this one, 26. Okay, so 64, 26, and 90. Okay, let's do one more. Let's do this one. Okay, we have the three sides, we have one that is 90, and we have B and A. So we already know that we don't need to use all of them. Let's choose one. Let's try tangent. Let's use tangent for both. Okay, because here we use sine, here we use cosine. Let's use tangent here. Okay, for tangent for A and tangent for B. Okay, so tangent of A, which is this one, okay, according to SOHCAHTOA, we know that it's opposite over adjacent. Okay, so in this angle, what is the opposite first? 12. And adjacent? 16. Okay, so it's going to be 12 over 16. Oh, wait, sorry. Gosh. This one's on the top. Okay, so tangent of A is equal to 12, sorry, over 16. Okay, so opposite inverse operation, 12 over 16. Okay, so we have inverse tangent of 12 over 16, 39. Okay, let's round up, 39. Okay, and let's use tangent B. Tangent B would be opposite, 16, over adjacent, 12. Okay, so 16 over 12. Okay, inverse operation. Okay, 16 over 12. Okay, and that's going to be inverse tangent of 16 over 12, 53. Do we know if this is correct? 53 plus 39, 90. Plus 90, 180. Okay, so we know it's correct. Okay, so this is why knowing this is important. Okay, and here we just proved that we can use either operation to find the same angle. Okay, so here I just did them all so that you can notice the difference. Okay, but technically we only need one, okay, to find an angle. Okay, now what happens here? Okay, when we need to find not the angles, but we need to find the sides. Okay, what do we need to know? First, we can use the Pythagorean theorem, right? Now, the Pythagorean theorem, okay, tells us that we have c to the square is equal to a to the square plus b to the square. Okay, but that means that we need to find one side, but we need two sides to find the other one. Or we can have this one and find this one. Or we can have this one and find this one. Okay, now in an exercise, okay, where we already have, when we don't have any of the sides, but let's say that we have at least the measurements of the angles. Okay, now what would happen if we have the measurements of the angles? Okay, if we have the measurements of the angles, we can find, okay, certain sides, but we need at least one, okay, so that we can find the other ones. Okay, so for example, here, okay, this exercise, you can find it on page 63. Okay, let me put it here. I'm going to put it here in the video. Okay, so we're working with the exercises on page 63, right? So here we have the same exercises that we're doing right now. Okay, now here, look at here. Look at this one. It says find the value of all trigonometric functions for the given angles. Okay, so here they're giving us the sides, right? So we have 6, 8, and 10. Now, what if we don't have these sides? What if we only have the angles? Okay, if we were to have the angles, we could use the angles to find the sides. Okay, I don't want to get into that exercise just yet. I just wanted to mention, okay, with this function, with this triangle, that we could find the measurements of the sides using the angles. Okay, because remember that when we have, for example, sine of A, okay, we know that sine of A, according to SOHCAHTOA, is what? The opposite over the hypotenuse. So what would happen if we already have this? Okay, what happens if we have sine of A? Okay, let's say that A, the measurement of angle A, let's say that A is 64. Okay, that means that angle B is going to be 26. Okay, so we have the measurements of the angles. Okay, so what do we find, okay, using sine of A? Sine of A, we know that it's opposite over hypotenuse. So what if we have sine of 64 is equal to opposite over hypotenuse? Okay, so sine of 64, let's put it here. Normal sine of 64, we know it's 0.89. Okay, so we have this. Okay, now what happens if we already have, okay, this is just an example, right? 64 and 26. But what if we have one of the sides and we need to find the other two? Okay, because a Pythagorean theorem, to find one side, we need two. But what if we only have one? Then we can use SOHCAHTOA to find the other two. Okay, so here, for example, we have that sine of 64 is 0.89 is equal to opposite over hypotenuse. Let's say that we have the hypotenuse. Let's say that the hypotenuse is 18. Okay, so that means that 0.89 is equal to the opposite side over 18. We can move this 18 that is dividing to this side. And we multiply 18 times 0.89, and then we're going to have the opposite side, which is going to be 18 times 0.89, 16. Let's use 16 as a, an equal number. A whole number. So the opposite side is 16. Okay, so sine of A, that means that this one is 60. Okay? That is when we have one side and we need two, right? So we have one side and we have the angles, so we can use the trigonometric functions to find the other two sides. Because once we have this side and we have this one, we can use the Pythagorean theorem. Okay? But we can also use the trigonometric functions. Okay? Since we already have A and we already have B, let's try to find B using the trigonometric functions. Sine of, which one uses, if we want to use 64, which one uses adjacent? Cosine, right? So we would say cosine of 64, okay, is equal to adjacent over hypotenuse, right? So adjacent is B, and the hypotenuse is 18, okay? So 18 times the cosine of 64 is going to be equal to side B. And if we simplify, we have cosine of 64 is this times 18. Let's put 9. 8, sorry. 7.89, let's round out to 8. Okay, so that means that B is equal to 8. Okay, this side. Okay, and that's how we use the trigonometric functions to find the sides of the triangle. Okay, but we would need to have one. Okay, if we only have one, we cannot use the Pythagorean theorem, because to find one side of the Pythagorean theorem, we need two sides. Okay, but if we have one side, then we can use the trigonometric functions using the angles to find the sides. Okay, so that's why I wanted to mention this type of exercise. When we have two sides, we can use the the Pythagorean theorem. But when we only have one side, but we have the measurements of the angles, then we can use the trigonometric functions to find the other two sides. Okay, so these type of exercises, you can find them on page 63 on your books, but remember to check out the link under this video for exercises that you will have to hand in. Okay, if you have any questions, please let me know.